Question 8 says, copy and complete the table of values for y equals 2x squared minus x minus 4 for minus 3 is less than or equal to x, and x is less than or equal to 3. And this is the table here. There are two ways to actually solve this question. Is either we use the table or tabular method, or we use the substitution method. Most people are used to the substitution method, but the table method gives you less stress, it's easier to solve, and the table method doesn't make your work rough, it makes it simple. But let me show you the substitution method. Now, for example, let's prove that this minus 3 gives us 17 using the equation. The equation says y equals 2x squared minus x minus 4. We take our value for s as minus 3. So when x is equal to minus 3, we'll find y. So y is equal to 2 into open bracket minus 3 squared, that's the value for x, and minus 3, because there's a minus here before the value for the x, which is minus 3. We have to be careful with that when we're solving. And the constant, which is minus 4. We say y equals to 2. We have our minus 3 squared, that's saying minus 3 times minus 3. Minus times minus is plus, 3 times 3 is 9. That's 2 times 9. Then we have minus 3. Minus 3 means you can't have these two signs without trying to group them together or turn them into one. So minus times minus is plus, so we have plus 3 minus 4. Y equals 2 times 9 is 18 plus 3 minus 4. Y is equal to 18 plus 3 gives you 21 minus 4. 21 minus 4 gives you 17. Now going back to the table, we see that when our x is minus 3, y is 17. For those who are not used to the table method, you can actually learn it today. And our equation is y equals 2x squared minus x minus 4. And the value or the range for x is minus 3 included to 3. So we can first write our x here. We write our range as minus 3, minus 2, minus 1, 0, 1, 2, 3. Now, what we're going to be writing next is the values here. So we'll take this as a whole. This is 2x squared. It comes with a positive, so you don't need to write the positive. So you just write 2x squared here. Then this x with this minus owns this sign. There's a 1 in front of it that is not. Most of the time we don't write 1x, so we just leave our x as x. So we have minus x. The x and the minus will be the second value. And for the last value, we have minus 4. The 4 and the minus will be there. Then we have our y. Since the minus 4 is a constant, has no s behind it, we have to repeat it all through the table. That's minus 4, minus 4, minus 4, minus 4, minus 4, minus 4, minus 4. Now for the first value of 2x squared, we take minus 3 and we insert minus 3 into this 2x squared. That means the value for our x is minus 3. So we have, for example, here we have 2 into open bracket minus 3 squared. Now our minus 3 squared is minus 3 times minus 3. Minus 3 times minus 3, minus times minus is plus, 3 times 3 is 9. So we have 9. And we still have this 2 because it was minus 3 squared. 2 times 9 will give you 18. Then we have the next value, which is minus x. So we know the value of our x under this table is minus 3. Then we have minus x. That's minus, we have minus x, then minus into open bracket minus 3. Because the value of our x itself is minus 3. So we have minus 3. So we join them together. Minus times minus gives us plus. So we have plus 3. Ignoring the value for the x, we can now add all these values together. We have 18 plus 3, that's 21. 21 plus minus 4, or minus 4, just with the sign. 21 minus 4 will give you plus 17. We can now take the second one so we can understand better. We have minus 2. We take minus 2 and use this equation to solve it. Now we have 2x squared on this line. So if it's 2x squared and we have minus 2, that means our x is minus 2. So we have 2 into open bracket minus 2 squared. Minus 2 squared means minus 2 times minus 2, that gives us plus 4. We have like minus 2 times minus 2. Minus times minus is plus. 2 times 2 is 4. So minus 2 squared is 4. That's 4 times the initial 2 will give you 8. So the value for this is 8. And for our minus x, for the value of x is minus 2. So we have our minus x, and we have that minus into open bracket minus 2, because the value of x here is minus 2. So we'll do minus times minus, that's plus 2. So the value for this is 2. We have 8 plus 2. We're not adding the range of the x when we're doing our addition. Just take the 3 values we've derived. So we have, or we've calculated. So we have 2 plus 8, that's 10. 10 minus 4, that's 6. And the next we have is minus 1. You have 2x squared. Then you have minus 1 squared. Minus 1 times minus 1 is plus 1. Plus 1 times 2 will give you 2. We have our value for minus x. Minus x when x is minus 1. So minus minus 1. That gives you plus 1. The value for this is 1. So we have 2 plus 1, 3. 3 minus 4. You're having 3, you're owing 4. That means you're owing more than you have. That means by the time you pay back, you still be owing 1. That's minus 1. The next value we're calculating for is 0. We have 2x squared when our x is 0. So you have our value of our x to be 0. 0 squared is 0. 0 times 2 is 0. We have our value for minus x. For our value for minus x when x is 0, so minus 0 is 0, so we have 0. So we have 0 plus 0 minus 4, that's still minus 4. Then we take our value for x is 1. For x is 1, we insert it there, that's 2 into bracket 1 squared. 1 squared is 1 times 1, 1. The answer of getting 1 squared times 2, that's 2. 2 times 1, 2. Our value for minus x when x is 1 is still minus 1, because we just replace our x with 1 and the minus is still there, that's minus 1. So we have 2 minus 1 minus 4. You have 2, you owe 1. By the time you pay back, you still be having 1, then you owe 4. By the time you pay back from what you owe, which is more, you still be owing 3, that's minus 3. For the value of 2, when x is 2, we insert it into this value for x. So we change it to 2. So we have 2 squared, that's 2 times 2, that's 4. 4 times this 2 in front, that's 8. Then we have minus x. We change, since we're working with 2, we change the x to 2, so it's still minus 2. So we have minus 2 here. Our answer will be 8 minus 2 is 6. 6 minus 4 will give you 2. Last value when x is 3. For the value of when x is 3, we insert 3 here. And we say 3 squared, that's 3 times 3, that's 9. 9 times 2 will give you 18. Then we'll go again. We say for the value of, for x is 3, using minus x, that's, we have our minus x here. So minus x, you just change the x to 3. That still gives us minus 3. We have for our answer, for our y, we have 18 minus 3. That gives you plus 15. Plus 15 minus 4. That gives you plus 11. So the value of this is 11. And this ends our table. After deriving our y values using the x values, we can write out our smaller table, which is x, y. We have for x minus 3, minus 2, minus 1, 0, 1, 2, 3. Then our y will be 17, 6, minus 1, minus 4, minus 3, 2, and 11. Number 8b says using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis, draw the graph of y equals 2x squared minus x minus 4 minus 3 is less than or equal to x, and x is less than or equal to 3. The next question has asked us to draw a graph, and in the first part we were able to get our values for y, and we've also been given the scale to work with, so we're not creating our own scale. The scale says on the x-axis you have 2 centimeters to 1 unit, on the y-axis you have 2 centimeters to 2 units. So let's start with our graph. This is our graph sheet, and on our graph sheet we have to draw the vertical axis, which is the y-axis. This is the y positive, this is the y negative. We'll draw the horizontal line, which is the x-axis. We have the x-axis positive, we have the x-axis negative. We've been given our scale. For those who don't really understand the graph, let me zoom in. If you have your graph sheet, for you to understand your scale, like saying 2 centimeters represents 1 unit. So what's actually 2 centimeters? Let's understand by starting with 1 centimeter. We have your graph book. You can take your ruler and measure from this point to this point. You discover the distance from here to here is 1 centimeter, and from here to here is 2 centimeters. So if you count 1, 2, 3, 4, 5, the fifth line that forms the small box in most graph book is slightly thicker than the usual internal 4 lines, but not as thick as the one of the 10th line. So we have the 10th line here, and the distance from here to here is actually 2 centimeters. And if not a perfect graph book, you have it close to 2 centimeters. So when they say 2 centimeters represents 1 unit or 2 centimeters represents 2 units, that means from here to here, the distance from here to here, which is 2 centimeters, if it were to be 1 unit, that means you indicate it in 1, like demanded on our x-axis. Then another 2 centimeters, you make it 2, and you keep going like that. As indicated in the question, we're told that on our y-axis, we should make 2 centimeters. Our scale on our y-axis is 2 centimeters to 2 units, and on our x-axis, 2 centimeters to 1 unit. We've actually made our labelings. So we have, this is your y-axis, and distance from here to here is 2 centimeters, which is 2 centimeters represents 2 units. So you keep going. For every 2 centimeters, you keep doing 2 units. That's 2, 4, 6, 8, 10. Then on our x-axis, it said 2 centimeters represents 1 unit. So the distance from here to here is 2 centimeters, as discussed earlier. And note, on the x-axis, this is the positive side, this is the negative side. On the y-axis, the positive side is up and the negative side is down. With that being done, we'll move to the next stage of plotting our graph. Using our table, the table we calculated, we'll start plotting the points. We start with the first one, which says when x is minus 3, y is 17. You know, x negative is on this side, this is minus 3, and our y is 17 is up. On the y-axis is a positive part of y. Zooming in, at the point of when x is minus 3, y is 17, we go when x is minus 3 and y is 17, that means we are going up. Since y is positive, we go up. And looking at this, if this is 16 and this is 18, in between 16 and 18 we have 17. 17 will actually be right in the middle, so this is 17. From there we get our point, first point, that's when x is minus 3, y is 17. We do that, then we mark out the point. This is it. And second coordinates are when x is minus 2, y is plus 6. So we'll go, this is x. When x is minus 2, y is plus 6. This is positive y. So we'll take a minus 2 and plus 6. So our second point will be here. The next line says when x is minus 1, y is minus 1. This is 0, this is negative 1 on the y-axis, so it's somewhere here. Next point is actually here. So here are our points. When x is minus 3, y is 17. This is minus 3 on the x, and we'll go 17 on the y positive axis. This is it. Second point is when x is minus 2, y is 6. When x is minus 2, still on positive y, we have it as 6. So we'll make the mark there. When x is minus 1, y is minus 1. So we'll come down here and make our point. When x is minus 1, y is also minus 1. Between 0 and minus 2, you have minus 1. So x here is minus 1, y is also minus 1. You make our mark here. Next point talks about when x is 0, y is minus 4. So we have our 0 point here on the x-axis and our minus 4 here on the y-axis. We come down the y. Next point says when x is 1, y is minus 3. We go down when x is 1, this is 0, this is 1 on the positive x. Y is negative, so we'll come down. So it's minus 3. In between minus 2 and minus 4, you have minus 3. We make our mark. When x is 2, y is 2. So when x is 2 on this, we'll go up the positive. That's y is 2. Then the last point says when x is 3, y is 11. We go up, we come to x is 3. We go up and search for 11. 11 is in between 10 and 12, so we have our 11 here, and on x is 3 we go up to 11, which is right in the middle. We'll make our mark. Once we are done with plotting all our points, we now join the points. If you look at this, this is actually a curve. The graph is coming this way and right down here and takes a curve back up. When you're joining your lines, some would use some elastic materials to do it. Some are very good with their French curves. But one thing I would advise is to take 3 points and join them together first, and you go around. And the best place to start is where you have the curve, where you think you have the curve. So you put your French curve here, your curving material, or your broom, or your elastic ruler, and get these 3 points first. So we'll go and put it and make this point first. Then we can now, from here, we join these 3 points, and we can now join these other 3 points and get our graph done. As discussed earlier, take our first 3 points. At the turning point, we'll make our curve. We'll stop here, then we'll take the other points. Next we're taking is these 3. We're joining these 3. And lastly, we go for this part. We've now finally completed our curved graph, which is shown here. The next is that we indicate the name of the graph with the equation itself on the side. Question 8CI says, use the graph to find the root of the equation y equals 2x squared minus x minus 4. So we know how to find the root of our graph. The root of our graph is where the curve hits the x-axis. So looking at this, if we zoom in to our graph, if you look closely at our graph, we'll see that at this point, the graph hits the x-axis on this side, takes a turn and hits the x-axis on this other side. So there are 2 points at which the graph makes contact or intercepts the x-axis. So we have at this point. The first point is somewhere lower than -1, because here we have our 0, we have our -1, heading towards -2. And looking at all these smaller lines, we have 10 of them. 1 divided by 10, since there are 10 lines, 1 divided by 10 will give you 0.1. So each of these lines is 0.1. So you have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, all the way. As stated, zooming into the graph, you see that at that point, as discussed earlier, this is the point where the curve hits the x-axis on this side and on this side. And the points are, this is -1, this is going to be -1.2. First point is x is equal to -1.2, and the second value is, now this is 1, we'll go 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and x is also 1.6. So our values for the roots of equation are -1.2 and x is 1.6. Question 8CII says, use the graph to find the value of x for which y increases as x increases. So understanding this question means you find the values for x for which y increases as x increases. You know, x increased, if you look at our graph, the table we have here, x was going from -3 to -2 to -1 to 0, 1 to 3. That's an increase in x. So where does it start showing an increase in x and a y2 was increasing? Now look at this first. The first point is when x increased from -3 to -2, y dropped from 17 to 6. So the graph kept going down as we kept moving on the x to the positive side of x. As x increased, y at this point was dropping until a particular point where it picks up and starts to rise. So as x increased, y somewhere starting from this point started increasing. A closer look at the graph, we'll see at this point, at this particular point, y started increasing as x was increasing to the positive. So we'll mark the point. Since we are looking for the range, we'll mark it straight up and we'll discover it is somewhere at, this is 0, and we know it's 0.1, 0.2, 0.3. So as x increased, y started increasing at 0.3, this particular point, 0.3. And it goes up and kept increasing until it got to the last point on the graph, which is 0.3, which is here, which is at x is 3. So we see that this is where we have our point. Our point for the range or the values of x, where we have our increase with y increase, as x increase and y increase, starts from 0.3 and goes right up to 3. Since it starts from 0.3, our answer is therefore x is greater than or equal to 0.3 and also less than or equal to 3. So it ranges from 0.3 up to 3, 0.3, 0.4, and so on up to 3. Our last question for question 8, which is 8C III. Use the graph to find the minimum point of y. The minimum point of y is the lowest point on the graph at y. Looking at our graph, the lowest point is actually below 4, -4. So we have the lowest point on the graph is actually somewhere below -4. So let's take a closer look at our graph. So we have it somewhere below the first line below -4. The lines in between, you can calculate them by counting them all. You count them 1, 2, 3, 4, 5. And since they represent 1, you divide 1 by 5 and you get 0.2. So 0.2 you've gotten means each of these is 0.2. So you have them 0.2, 0.4, 0.6, 0.8. You keep adding 0.2 to each value. And it is done by counting all the inner lines, skipping the 0. Since there are 5 of them and you have this particular point to represent 1, so you divide 1 by 5. So you get 1 divided by 5 will give you 0.2. And for whatever scale you're using, that same format still works. You count the amount of lines, then the particular number that line represents, you divide it by the amount of lines. Then you get the inner divisions. Since the inner lines are at 0.2 as discussed, because you have 4 and 5, and you have to go 0.2, 0.4, 0.6, 0.8, then 5.0. So the minimum value for y is actually -4.2.